want to do a little overview of Unit 2. The big idea is differentiation. And we're going to talk about its definition and fundamental properties and then go beyond it in chapters 3 and 4. All right, so what is differentiation? What is the derivative? Well, we know about average rates of change. Average rates of change of this parabola right here is the slope between those dots, or this is a purple. The average rate of change is that slope. All right, instantaneous rate of change is the slope at one point, right there. So we actually find slope with 1 point instead of 2. And that is the idea of calculus, this instantaneous rate of change. And we'll talk about that. The average rate of change is what you've done in every class so far. We're just trying, on average, how is this graph changing over this frame of span of interval of time or interval of values. But we want the instantaneous rate of change. What exactly is the slope of that? And they call it a tangent line. All right. Now there's some notations for the instantaneous rate of change. And they call it the derivative, by the way. Instantaneous rate of change is the derivative, differentiation. The notations are these types of notations right here. We'll get used to it. Don't worry about it right now. And so what you look at a graph here, you can see it's not continuous at -3. It's not continuous here at 2. But we're going to talk about what is the slope. For instance, right here, it looks like the slope is 0. At the top of a graph, or at the bottom of the graph, the slope is 0. Right here, the slope is up and down, which is undefined. So we'll start talking about when the slopes get weird and undefined and stuff like that. All right? And then we look at this. Well, for this graph, what we have here, I want to talk about, the function here, we'll call this, is f. And what the blue graph is f prime of x. So this graph is f, and this graph is f prime of x. For this parabola, can't you tell that the slopes are going up, 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 instantaneous range is up, 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 but right here at the top, the slope is 0. See, the slope value is 0. See, all the values of the derivative are positive. And then here, it starts going down, 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 downhill, downhill, downhill. The slopes are all negative. See how the values of the slopes are negative. And we're going to learn the basic idea of this, but we'll talk more about the graphs later in future units and stuff like that. But it's basically talking about, see, this graph is going uphill, uphill, and then it stops. So the values of the slopes are positive. And then the values of the slopes are negative. And that's going to be interesting. But what happens is, for every function has another function that describes the rate of changes, the instantaneous rate of changes. And we call that the derivative. So you can make a graph of it, you can make an equation of it, and you will see a comparison of this. Now, so for instance, if I want f of x, all right, which is this graph, what is the equation of that line right there? Well, it's simple as this. It is simple little process. It's going to be 3 minus 2x. That is the derivative of this. And you'll learn how to do that. And if you look at that line right there, if you looked up here, it would cross at 3, and it's going down 2 over 1. So this would actually be the graph of that blue line, and the red is this function. And we'll talk about that. Lastly, find the derivative of a function. So we're going to have to find, how did I do this? How did I find the derivative? How did I find this equation of all the slopes of a function? Well, we're going to learn how to do it with basic polynomial functions, exponents, logs, and all your trig functions. So we're going to learn a lot of little entry-level derivatives, equations, such that you can see the original function and find its function that finds its instantaneous rates of changes at any point for that specific function, but only of some basic ones. And in future units, we'll go deeper with some deeper ideas.